multiplication and division of mixed numbers, 4.3 right here. Again, it's just going to add, it pretty much adds a step at the beginning and the end, but it's essentially the same step, okay? And we'll get into that. The first part of this lesson, 4.3, is stuff that we've seen before, okay? So if you're like, yeah, I feel pretty good about changing mixed numbers to improper fractions and improper fractions to mixed numbers, then really this first part of the lesson will be review. I mean, it's review either way, but if you feel comfortable with that stuff, then I mean, you could extend your break right now and just come back in a few minutes, okay? But in any case, I do feel like it's necessary to review these and look at just an example of each. Because it's required that we be able to do this when we operate with fractions, whether it's, or mixed numbers rather, which is part of the section, right? We're looking at multiplication and division of mixed numbers. So what you're going to be doing when you're operating with these mixed numbers is first, you're going to change them into their improper fractions. Then you'll multiply or divide, it doesn't matter which. But in the end, if you have an improper fraction, you'll need to change that improper fraction back into a mixed number, at least for this section. And it should specify on the assignment that it wants the answers as mixed numbers. So that'll be crucial again, because it will not accept improper fractions for the most part in this section. Okay, so again, this is a cycle method right here that we're looking at. So you take the whole number of the mixed number, multiply it by the denominator, and then you add that value, that product, to the numerator, and that would give you a new numerator. Remember, though, that for whatever you get, the denominator will stay the same. All right, so you'll do a times c, figure out that product, add b, that'll be your new numerator. We don't know what this is, but the c value in the denominator, it will always stay the same. Of course, you'll look for any simplification that can be performed, but it shouldn't need to be when we're looking at formal mixed numbers. And do remember that formal mixed numbers need the fraction to be a proper fraction in the mixed number. Also, it needs to be fully simplified. So just a quick example of changing a mixed number into an improper fraction. So once again, I know that whatever I get out of this, my denominator will stay the same. That's good. So I'm going to keep it the same, all right? All we're doing is solving for the numerator. So again, cycle method would show that we'd have 2 times 9 first, which is 18. And then we would need to add the 7 right there. So I'd do 18 plus 7. 8 plus 7 is 15. Carry the 1. 1 plus 1 is 2, 25. So that would be my new numerator. And yeah, that gives us actually the full fraction right there of 25 ninths. So again, this is what you would do in the beginning of these problems if you're presented with a mixed number like we were right there. So changing improper fractions to mixed numbers, now we're using long division. And remember that the quotient will be the whole number. The remainder is the numerator of the fractional part of the mixed number. And then whatever the denominator is, it should stay the same. Of course, you could look to simplify these, but they really shouldn't need to be if we come to the end of those. Now, at the end of a problem, after performing the operation of multiplication or division, there could be some simplification, but not when we're changing, usually not when we're changing improper fractions to mixed numbers. If it could be simplified, then you could just look at the improper fraction and simplify it there. Again, that's not required that you do that, but some students prefer to do it, which is why I'm going over it. So once again, a quick review on changing this improper fraction. And yeah, I should have mentioned this before, but an improper fraction, remember, is where the numerator is bigger than the denominator. So 45 over 4, that would read for long division 45, but divided by the denominator 4. And yes, remember that whatever the denominator is, it will stay the denominator. It should stay the denominator for the fractional part of the mixed number. So again, I'll put the whole value here and then the numerator there. The whole value is the quotient. The numerator is the remainder. So I see in this example, 4 goes into 4 once. 1 times 4 is 4, so that subtracts. Zeros out the 4s, I'll drop the 5. 4 goes into 5 once. Again, 1 times 4 is 4. And when I subtract that, that takes care of all the ones. So that's my remainder right there. Okay, so my quotient was 11. My remainder down here, in fact, I'll do it in orange. My remainder at the bottom here is 1, so that would be the numerator. So 45 fourths is the same as 11 and 1/4. So of course, if you wanted to just make sure that this was correct, you could use cycle method to change it back into an improper fraction, but that's only if you do want to check. And yes, it would work. 11 times 4 is 44, plus 1 is 45 fourths. There's the mixed number. So again, this is important because we will need to change the mixed numbers into their improper fractions. And while this is maybe an oversimplification right here, it says to operate, and of course we're only dealing with multiplication and division right now of the mixed numbers. So you'll multiply or divide. Really, you're just multiplying, because we'll always change the division into multiplication, just like we saw in that last section. And then if you have a improper fraction as your answer, just change it back into a mixed number, just like we did on these last two examples, which were review. So simplify, write your final answer as a mixed number. Okay, we can do that. Now, by the way, there is more than one way to do these types, especially where we're just multiplying by a whole value. But I want to skip that right now. I don't even want to show it to you because I worry that it can cause more confusion. And it's prone to errors. It's prone to make more, students are prone to make more errors using that method than they will if we just stick to our strategy right now. Okay, so I'm going to take any mixed numbers and change them into improper fractions. Now you could say right now that the 2 is already an improper fraction. That would be fine. 2 over 1. Okay, that's fine. Now we'll need that for the multiplication. That's true. But I need to change the 4 1/3 into an improper fraction. So let's do that. And whatever I get out of that improper fraction, of course, it'll be multiplied by 2 over 1. All right, so let's look. Again, cycle method would show 4 times 3. And this is just the numerator part of the fraction. 4 times 3 is 12. Then I'll add the 1 numerator, which is 13. So that's my new numerator, is 13 there. And the 3 denominator here will stay the denominator of the new improper fraction. New, but same. It's the same value, right? So at this point now, we will do the operation. So I'd say, okay, we got 13 times 2, which is 26. I'll show the multiplication there. 13 times 2, 2 times 3 is 6, 2 times 1 is 2. 26, that's what we got. And then in the denominator, I've got 3 times 1, which is 3. So right now, after the multiplication, I have 26 thirds. Now, that was okay in the last section because it was okay with improper fractions. But in this section, we want mixed numbers. So we need to take that 26 thirds, and yeah, we'll use long division to divide it. But again, this will only produce the numerator and whole value of the mixed number. The denominator 3 will stay. But yeah, we are dividing by 3 there. So let's see what we get. 3 goes into 2, won't go into 2, but it will go into 26 8 times. 8 times 3 is 24. When I subtract, I get 2, and then since I used up all my 1s there, that's all that remains. So the 8 quotient is the whole value of the mixed number, and then the remainder of 2 here is the numerator of the mixed number. And, well, I don't see that it can be simplified. I should have mentioned that here. I did check, but I just kind of mentally did it without saying it out loud. 26 thirds cannot be further simplified. In fact, none of this could be cross-simplified either. So we ended up with 26 thirds either way, which now as a mixed number is 8 2/3. So simplify, write your answer as a mixed number. No problem. We can do that. It should be easy. Well, I said easy, but it should be doable. That sounds better. But yeah, we've got the 2/3. Again, we don't need to worry about that. But the 6 4/5 mixed number. Again, any mixed numbers in the beginning of these problems, you should change into improper fractions. Now, do keep in mind that when we're changing these into improper fractions, that will be true when we start adding and subtracting the fractions as well, which will work a little bit different, okay? So cycle method, for me, that's how I'm going to change my mixed numbers into improper fractions. So I would say, well, 6 times 5 there, whole number times the denominator, that's 30. 6 times 5 is 30. And then add the 4 there in the numerator. That's a poor arrow, but I'm trying. So add the 4 to the 30 to get, well, 34. So that mixed number becomes a improper fraction with 34 as its numerator. And that denominator 5, again, it will stay a 5. So it's 34 fifths. And we are dealing with multiplication, that's nice, of 2/3. So we're just looking at two factors. Do be careful, okay? Because, and I know I've said this already, but we're in that last section, which we did today, where we did division. Sometimes we see multiplication, and it's like, well, I got to reciprocate this fraction. Be careful not to do that and to get these mixed up. Actually, do take your time and look. Make sure that it's already multiplication, which means there's no need to reciprocate this second value right here, this factor for us. Okay, well, now that we've done that, no need for reciprocation because it's already multiplication. Now, I am checking to see if we could cross-simplify, and I don't see anything. Okay, in fact, I'll show this with the prime factorization. Maybe that would be a little bit more helpful. 34 is 17 times 2, both of which are prime. So even though you can change, and I'll show this, right, we got the 5 there, and we got the 2/3 here. 17 times 2. If I break the 34 into 17 times 2, you'll notice that there is no matches in the numerator or denominator. So, yeah, it looks like we'll just have to do the multiplication straight across anyways. So just because 17 times 2 is 34, I'll just show it back here. 34 times 2, let's do that. 34 times 2 stacked. 2 times 4 is 8. 2 times 3 is 6. I get 68 there. That's my numerator. And in the denominator, we got, well, just 5 times 3, which is 15. That's doable. All right, well, we have that, but it's an improper fraction, and we don't want improper fractions as our answers. We want mixed numbers. So we need to do this division, 68 divided by 15. So I need some multiples of 15 just so, because we don't expect you to have these memorized. If you do, that's fine, but let's assume that we don't, okay? So the first multiple of 15 is just 15, so add another 15 there, which is 30. That's my second multiple. I'll kind of check these off so I know which ones I'm looking at. And remember, since we're only looking at 68, really, I only need to go that high. So add another 15. That'd be 45. That's my third multiple. If you add another 15, that's 60. So that's my fourth multiple right there. Which means that, yeah, 15 won't go into 6. I'm looking at the long division now. 15 will not go into 6, but it will go into 68, just like we saw right there 4 times. 4 times 15 is 60. When I subtract that, I'll have a remainder. 8 minus 0 is 8. And then the 6 is 0 out right there. Okay? So what do we get as our final answer? Well, we got the quotient that's 4. So that's our whole number in the mixed number. The denominator will stay 15. But our numerator is the remainder there of 8. So I get 4 and 8/15. I hope that's, I mean, it's colorful and it's pretty, but I hope that the colors are not too confusing on that. I'm trying to color code where they came from so that you can tell. All right, so 4 and 8/15. Again, I would just kind of double check here at the end. Could 8/15 be further simplified? And no, it cannot. So that's our final answer. Well, of course, we saw in that first example where we multiplied by a whole value, then we multiplied by a proper fraction. Now we got two mixed numbers being multiplied. No problem, right? Because we know that we're just going to change them into improper fractions and then multiply straight across. And just based on everyone so far, I would assume that everyone feels pretty good about that, which is great news. So just using my cycle method on this, 3 1/2 first. Again, that's 3 times 2 first, which is 6. And then to complete the cycle, you'll add the 1 numerator, which is 7. So as an improper fraction, 3 and 1/2 becomes 7 over 2. Remember that denominator stays the same as 2 right there. We are multiplying here, so that's okay. And I'll use different colors on the second set, but 2 times 5 to start out with. Again, using cycle method, that's 10. And then add the 2 numerator. 10 plus 2 is 12. So 2 and 2/5 becomes 12 fifths. Oh, okay. So I see on this one I can use some cross simplification now, now that we have these as improper fractions. And what I'm looking at specifically is the 2 and the 12. I know both of those are divisible by 2. So I'll take the 12 and divide it by 2, and also the 2 and divide it by 2. So that's going to change those two fractions. It won't change the numbers, the 7 and the 5 there. That's still going to be 7 in that numerator, and a 5 in that denominator. But 2 divided by 2 in the denominator becomes 1. And 12 divided by 2 in that numerator becomes 6. So that simplified it for us. I don't see anything else that could be further simplified, specifically with the 5. Of course, the 1 is already simplified. So let's give ourselves a little bit more space here if I can. There we go. So what do we get out of this? From the multiplication, I got 7 times 6 there in my numerator. 7 times 6 is 42. And then in the denominator, I've got 1 times 5, which is 5. So this is 42 over 5. And yeah, we need to use long division to change that into the mixed number. So 42 divided by 5. This one's be pretty direct. 5 will go into 40. It won't go into 4, but 42 8 times. 8 times 5 is 40. So whatever I get out of this is my remainder. Looks like that's 2. And we need those for the mixed number. Of course, the denominator was already 5, so it will stay a denominator 5 in the fractional part of the mixed number. Our quotient 8 there is our whole value. So 8 and something fifths, well, 8 and 2/5. There we go. Yeah, and again, I just checked, just a quick check, 2/5. Yeah, that cannot be further simplified. It shouldn't be, because we simplified here. But if it were able to, like we missed something, that's okay. If you see that that fraction could be further simplified, do it. But this one cannot. So let's go ahead and divide these. 4 and 3/5 divided by 5. Let's give ourselves some space. And while we will be reciprocating that 5, right, we're going to make it 5 over 1. Let's change the 4 and 3/5 into an improper fraction first. So I like cycle method, so I got 4 times 5, which is 20. But to finish off the cycle, we'll have to add the numerator 20 plus 3, which is, 23. So 4 and 3/5 then becomes 23 over, and yeah, we're going to keep that denominator the same as 5. Now this is showing as divide by 5, and again I'll show it as 5 over 1. But we need to change this into a multiplication problem so we can just multiply straight across. And our dividend, 23/5, is not going to be affected by the change in operation to multiplication, but the divisor will. Where it was 5 over 1, now it will be shown as 1 over 5. Again, that's reciprocated right there. So we'll perform this multiplication at this time. And I don't see anything that could be cross-simplified at this point. 23 is prime. Same with 5 already. So we'll just multiply straight across. 23 times 1 is 23. That's my numerator. And then in the denominators, 5 times 5 is 25. A little bit more space, but that's our final answer. Now you should ask, well, why didn't you change that into a mixed number? It's because it's a proper fraction already. So there's no need to write it as a mixed number. It's already, proper fraction. You could say that the whole value is 0, but it shouldn't require anything like that on the assignment. So from time to time, you'll see examples like this where, you won't need to change that back into a mixed number. Just like we saw in the steps for this, right? That last step, sometimes it's not necessary, and that's if you end with a proper fraction like we did right there. So simplifying, and again, this is division of 2 mixed numbers. That's good stuff right here. In fact, this one I think we'll end up with a proper fraction in the end, but let's find out. So I'll give ourselves some space. I'll use cycle method again to change these into their improper fraction. So let's start there with 2 times 3, which is 6. And then to finish off the cycle, we'll add the 2 there, numerator, to make that 8. All right. So that fraction, that mixed number, 2 2/3, becomes, that's 8. That's what we found from cycle method. That's our numerator, all over 3, 8/3. It's the same exact value, just shown in a different way. And yes, I'll keep the division for now, although we'll change it to multiplication. And then we'll use cycle method on the 5 3/4. So that would be 5 times 4 first, which is 20. And then we'll add the 3 there, numerator, to get 23. So as a fraction, 5 3/4 becomes 23/4. Now I'll say this, I would imagine that some of you are doing that pretty quick. In fact, showing all this work down here may not be necessary for you. And again, that comes with a lot of experience. If you feel like you have that experience, showing this work, I would say, becomes unnecessary, although it's good to just see your work sometimes so that if you make mistakes, you can go back and trace those, okay? But if you're doing it in your head, that's okay. Just, again, be careful. I make mistakes all the time when I do stuff in my head. You've seen that before. But if you feel comfortable doing that, I'm not going to object to it. Now we have 8/3 divided by 23/4 rather. The 8/3, that's our dividend. So it's going to stay 8/3. And I say it stays that way because I am going to change the operation, which is going to flip or reciprocate the 23/4 into 4 20/3. Yeah, that looks pretty good. Oh boy, yeah, I didn't expect this, but I don't see that any of this stuff can be simplified at this point either. So there wouldn't be any need for cross simplification. You could say, well, the 8 and 4, those are going to divide up into 2s. That'd be 2 times 2 times 2. 4 is 2 times 2. But 23 is already prime, so there's not really any primes that match. So, well, we're just going to multiply these straight across then. So it will be 8 times 4. That's our numerator. That's 32. And then the denominator, we'll show the work for this one. 23 times 3. 3 times 3 is 9. And then 3 times 2 is 6. So we get 69 as our denominator. So we get 32 over 69. And yes, this is already a proper fraction because the numerator is smaller than the denominator. So there's no need to change this into a mixed number. Again, you may see that from time to time on the assignment, homework. You could see it on quizzes or tests as well. This one's going to produce an improper fraction when we finish the operation. So we'll have to change this one into a mixed number. That's good. It's good to see that from time to time. But like I said before, the first thing we're going to do on this is we're going to switch that 5 3/4 into a improper fraction. So I'm going to use cycle method. Right, 5 times 4, start out with, that's 20. And then I'll add the 3 numerator there to the 20 to make that 23. So that's my new numerator of the improper fraction, 23. And yep, the denominator just stays the same as 4. So we are dividing, so I'm going to show that division symbol. We'll change it to multiplication. The 1/2, though, I don't need to change that into a mixed number. Now, I'm going to go back to the experience thing. Some of you at this point would have already changed this into multiplication by 2 over 1. That's okay if you do. So for some of you at this point, even right now, you're like, this is too many steps for me. That's okay. Again, I appreciate you being patient because not everyone can do that at this time. But again, with some experience, you may end up doing that and skipping this, what I've shown in this step. So you would have essentially deferred to this next step. So again, our divisor is going to stay our dividend will stay the same, 23/4. But now I'm going to change the operation of multiplication, and we're going to reciprocate that fraction of 1 over 2 into 2 over 1. So again, some of you skipped this step and went straight into this one, and that's good if you did, okay? It's okay if you did. If you didn't, that's okay too. Now at this point, I would see that I'll use, I don't know. I guess I'll use prime factorization on this one. So I'll split the 4 up into 2 and 2 on this. Okay. So while not everyone will need all these steps, if you do, that's good. If you don't, you may have done it a different way and come up with the same answer, but your answer will be the same. So the 4, though, I've now split up into 2 times 2. All right. So now that I've done that, I can see that I've got a matching 2 in purple with a matching 2 in green. But it's crucial that, and I'm doing this because one's in the numerator, one is in the denominator. When I cross them out, they become phantom ones. And that just makes the multiplication just a little bit easier, right? So, I mean, we're still going to end up with a fraction on this, and we'll change it to a mixed number. But I'd say, well, the 23, I don't really have anything to multiply it by, so it's going to stay 23. And you could say here in the denominator you got 2 times 1, but it's still 2. Last thing I really need to do on this is to change the 23 over 2 into a mixed number. So let's go ahead and do that now. So that'd be 23 divided by 2. I'll use long division. I hope that's okay. 2 will go into 2 one time. 1 times 2 is 2. And zeroes out the 2, so I'll drop the 3. 2 will go into 3 one time. 1 times 2, seems like we've seen that before. But that gives me a remainder. I'll use a different color here. A remainder of 1. And that remainder is crucial because it's part of the mixed number. So the quotient of 11, of course, that's the whole value. But like I said, that remainder of 1, that's the numerator of the fractional part of the mixed number. And the denominator just stays the same as 2. So I get 11 and 1/2 as my final answer. Again, you could check, but the 1/2, that's fully simplified right there. So the first thing I would notice on this one, and again, this may come with some experience. I don't really know, but I've said this before, and I tried to say it many times. Anything divided by itself is 1. If you notice that right off the bat on this one and knew that it was 1, you're done. Okay. Now I'm gonna assume that not everyone noticed that, so I'm gonna take that away and operate with this. Okay. So let's say we didn't notice that, and we're gonna operate with this. That's okay. Let's go ahead and use some cycle method on this stuff, right? So 4 times 2, which is 8. And then I would add the 1 numerator right there. I'm just changing these into improper fractions. So 4 and 1/2 becomes now an improper fraction of 9 over, yeah, the denominator will stay the same as 2. We'll keep the operation the same. And yeah, you can do that cycle method again, but you should realize that it's going to be the same thing, right? 4 times 2 is 8. Now, if you didn't, that's okay. You can still perform the cycle method. You'll still get the same answer. And then add the 1 numerator to get 9 right there as well. So it's 9 over 2 divided by, well, 9 over 2. We're going to keep that denominator the same also. Well, at this point, we would say let's change this into multiplication. So the dividend will stay the same as 9 over 2, but we'll change the operation to multiplication, which we can do by reciprocating this divisor of 9 over 2 to be now 2 over 9. Now at this point you could notice that you could use cross simplification on the 9s and 2s. I'm going to assume, well, I'm going to proceed as though you didn't notice that. And in fact, on this one, I'll just do straight multiplication on this one. I don't know. I just feel like I should. So 9 times 2 in the numerator is 18. And then in the denominator, 2 times 9, also 18. And yeah, both of these are simplifiable by, well, 18. So I'll divide both by 18, which really just gives me 1 over 1. And again, this is where we need to remember that that wouldn't necessarily be considered fully simplified until you wrote it as just 1. Okay, and that's the answer that I showed in the beginning. I didn't mean to cause a spoiler. Maybe I should have said it's a spoiler alert on that beginning part. But however you do it, and again, this is longer, of course, if you didn't realize that in the beginning. But what is important is not how long it takes, but that you get the same answer. All right, and yeah, this answer right here is 1.